quick intro from me, then I'll hand it over to Pablo for a screen share. So, I mean, the essence of our working group here, right, has been kind of collaboration and ways to support interoperability among USD and glTF. And a key part of that is tooling, and especially things that are out there that are open source that the community is able to use. So I think we have the perfect example of the education sessions that we're looking for here. So Pablo is the creator of GUC, and am I saying that right? GUC, GUC? How do you say it?
Well, as a German, I pronounce it even differently.
Okay. All right. Well,
I don't think there's a correct pronunciation.
Okay. So this is a very popular glTF to USD converter, and you have a lot of fans here, by the way, Pablo. I want you to know that we really appreciate the contributions that you've made
really?
To the open source. Oh yeah, people are always talking about it and praising your work. So we're looking forward to learning from you today. And then in addition, we have Keith from Adobe here, and as folks know, Adobe recently put out their USD file formats plugins, which includes support for several different formats, but one that, of course, we're very excited about is glTF, and this is both directions, both glTF to USD and USD to glTF, and of course, bringing glTF into the USD object model at runtime. So I think that's another awesome open source contribution. I'm looking forward to hearing directly from Keith and Adobe. I was thinking, so since Adam couldn't make it, I was going to have all three folks present and then do Q&A. But given that we have like 50 minutes and two presenters, I'm thinking maybe if it's Keith and Pablo, it's okay with you, maybe Pablo, if you present, and then we could do some Q&A, and then Keith presents and we could do Q&A. And then for any folks who want to stay even past the hour, we always do an optional water cooler thereafter. So.
Sounds good.
Yeah, sounds great.
Cool. All right. Appreciate it, guys. So Pablo, I'll stop the screen share, then it's all yours.
First of all, thank you very much for inviting me. I'm going to tell you about JUC. It's a glTF to USD converter. And here's a small teaser image. On the left side, you can see a converted asset, a USD file, rendered in Pixar Storm Renderer. And on the right side, you can see the original asset in the glTF sample viewer. First, a few words about me, since I'm the maintainer of this project. I'm Pablo, I'm from Germany, and I'm a rendering engineer at Chaos. I'm active in the Academy Software Foundation Slack, and I'm also a contributor to open source projects like MaterialX, Blender, and USD. And I created JUC. This stands for glTF to USD converter, and you can find it on GitHub. It was created 2 years ago. Back then, I looked at the landscape of the conversion tooling and noticed that most of the projects were unmaintained, or in case of Apple, not really open source across platform. So I saw that there was a gap between these two technologies. On one side, glTF already being very popular in the industry, and USD, of course, a bit less known, but definitely an emergent technology. So I decided to jump in and become this link. And this project is pretty personal. It has nothing to do with Chaos, by the way. Also, it's written in C++, and it's permissively licensed under the Apache 2 license. I'm pretty happy with the current state of the project. It supports most of the glTF features. There's a caveat though, which is animation support is currently missing. I will talk about it later. It also supports direct export to USDZ files and more notably MaterialX. It also has an SDF plugin and compiles against the latest USD versions. I actually have a GitHub Actions pipeline that makes sure that all the major compilers are covered. And it also supports a number of extensions. You can see them on the right side. I think the variance extensions is probably very interesting. I'm not sure if there's another converter that supports variance. And I'm currently working on the unlimited extension. So let's say you want to use JUC. So how do you do that? Of course, you need to program. I offer pre-built binaries from the GitHub Actions workflows for free operating systems. But you can also build it yourself, of course. There's only one self-contained dependency besides of USD. So it's pretty lightweight. And then you have 3 options to use it. First, you can use the command line interface. Basically, you just pass in the input and the output file paths, and then some additional arguments. For instance, if you want to enable MaterialX support, or which kind of material variant should be the default. You can also use the SDF plugin. So if you don't know what SDF is, it's basically a subsystem of USD that allows USD to interpret non-USD files in a transparent way as USD files. So in this example, I double-clicked a glTF file, and this then opened USD view, and the conversion to the USD data model was implicit here. And lastly, you can use JAG as a library because it has a C header, which of course also allows people to write bindings for other languages. JAG also has a test suite with more than 200 tests. Every time I push something, all these assets get converted and then also check the USD checker. I also do graphical tests locally, and I use Pixar Storm Runner for that, and a perceptual heuristic. So I mentioned that it supports MaterialX, and I wanted to give a bit more context on that. First, I want to highlight why it's important, and then also how exactly the support works. So basically, people usually convert glTF to use the previous surface, but this is inherently flawed. You never will get the same results, of course, because it's a very different standard. It has a different shading model. Things like normal maps are underspecified, and you can't multiply by vertex colors. So in order to properly convert a glTF asset to USD, you need MaterialX. And I use the glTF PBR node from the MaterialX project for that. Basically, the converter instantiates this node. You can see the definition of the node on the right with all the inputs. And then I also create shaded networks and nodes that connect and fill up these inputs. And you can tell the converter whether it should write these MaterialX shading graphs inside of MaterialX files or whether they should be inlined in USD files. So just as an example, if you have a material with a base color, the converter creates this kind of shading graph. Basically, I look at the glTF spec, and the glTF spec says that the base color consists of the base color factor from the material. So I create a constant at the very top. And then this factor needs to be multiplied by the vertex colors. So I read the vertex colors from the prim bars using the node on the left, a geomprop value node. And this needs to be multiplied with the texture. So I also read the texture using a node at the very bottom. And then I also generate nodes to multiply the output values. And this is then how the output graph looks like. So there's this elephant in the room that currently does not support animations. And there's a good reason for that, because currently animation splines are not really supported in USD, and you have to bake them into transforms. And this works somewhat well for certain interpolation modes like step and linear. But if you have like a cubic spline, then you end up with a lot of transformations depending on the step size. And it's, of course, not really performant, and you can't really work with the output file. So I was kind of waiting for a better approach, and there is light on the horizon because Pixar has published a proposal, the spline animation proposal. And this essentially allows me to encode these animation splines that glTF has inside of USD. And of course, renderers can then use them. There's another small issue, which is that there currently is only one animation per layer, which is one USD file. But for that, there actually is a proposal. Unfortunately, it's still in the draft state, but perhaps this gets addressed at some point too. And if you're interested in these proposals, you can head over to the Pixar OpenUSD proposals repository and have a look at the text. Also, I think there's a lot of discussions going on related to animations and skinning in the Academy Software Foundation USD Working Group Games channel. And when it comes to skinning, I have the impression that skinning is usually used in conjunction with animations. So it kind of depends on this feature. and I want to tackle it later. I have some preliminary roadmap for the next version, which is going to be a minor version. I want to finish up this unlit extension. I currently use explicit primvar reading in shaded networks. I think that's the correct way to do it because it's not ambiguous in any way. However, I've noticed that not all runtimes support this, like I think Apple Quick Look. So one idea that I want to look into is making this configurable to kind of omit these nodes and let the renderer decide which primvars are used, let's say for the texture coordinate set. I also want to offer ARM binaries for the new devices and then have some minor improvements which I want to implement. And then for the big release, of course, animations. And that's about it. So if you want anything in this project, let me know, create a GitHub issue. Unfortunately, there has not been a lot of feedback until now. And also I'm going to be at FMX next month on Wednesday. So perhaps we'll see each other. And I hope you found this interesting and perhaps you have some questions.
Awesome job. Thank you, Pablo. All right, good timing as well. So plenty of time for questions. Who has the first one?
Oh, Leonard's got the first one, although I had one too. But I think Leonard
Okay.
should go. I think Leonard should go.
Leonard, then Guy. All right.
Anyway, I was curious as to how far along on the list of glTF extensions have you progressed?
Well, I try to cover most of the KHR extensions. You've seen there already quite a lot. There are some which have yet to be ratified, which would be pretty easy to implement, like audio. It would also, of course, be very interesting for this group. But of course, there are also some important extensions that have not implemented, like Draco. And I'm kind of dependent on feedback from you guys because there are not really statistics on which extensions are used a lot and which are not. So please give me feedback.
Yeah, that's a general problem about usage. The one thing I would like, not every not every non-KHR, there are extensions that have been ratified that are not KHR, and in particular WebP and a couple of the other ones might fit in that category that should be up. So don't depend upon the prefix to determine usage.
Yeah, I think extensions like the IAS extensions, cross-vendor, would also be very interesting.
Yeah, okay. Thank you.
I would also have a question, but I think Guys first.
Yeah, I just want to real quickly. So Pablo, thank you. Obviously, we've seen this work and really appreciate it. I had a question as to whether you had a chance to look at the Autodesk file format plugins that were recently open sourced, and do you see any potential for sort of synthesizing that work together with what you've already done?
Yeah, I had a look. Of course, they're very similar because they try to achieve the same thing. Of course, there are some differences. Like again, there's Autodesk. Well, it's not Autodesk. It's
Adobe. Sorry,
Adobe, right? But I think they support like Draco and neural graphics primitives and some Adobe material extensions, some more. So basically, I think the major difference is extension support. But of course, there are also probably structural differences with the converted assets. I wanted to have a look at that. I haven't done so yet.
okay.
Regarding any kind of combined effort, I haven't really thought about that.
Okay. I mean, the reason I ask is obviously, you know, Chaos is now, and I know this is not a Chaos thing, you did it on your own, but Chaos being a member of AOUSD, Adobe being a member of AOUSD, there's been a lot of discussion about, hey, can we combine forces with the best parts of what you've done and the best parts of kind of what they've done, and also what NVIDIA has done with our own plugin, because everyone's was writing their own. Instead of having 50 of these, if we could have, you know, one or two that we think you know, serve most of the needs. It would definitely make it easier when we do the glTF to USD interoperability piece that AOUSD and Kronos are trying to work on together, that I mentioned earlier that Mike's leading.
I think the most interesting viewport on that question is that of the governance. Like, it's for one, the Adobe file system plugins, they cover multiple files, and also it's from one company, whereas I try to be independent.
And I think that's why we were considering finding a way to do it within the lens of AOUSD and Chronos, because it gives some amount of neutrality there. But yeah, we should have further discussions on it, but I'm glad you've looked at least have a chance to look at the plugins and note the difference. Thanks.
I can comment briefly on this, and that's like the Adobe intention with open sourcing these plugins were not to own them as Adobe in the long term. We're hoping to donate it to a better place for it to be managed. Let's
Guido has asked if that could be an AOUSD, and we've said sure.
And Mike, did you want to chime in with your questions?
Yeah, no, I mean, overall, just like I said, like impressive work. It's great to see that you were able to kind of do this, especially independently. And from a Cronus perspective, our long-term objective is to make glTF a more friendly, usable, interoperable piece of 3D content. We never anticipate it to be like an authoring level format as USD is, but we want people to be able to plug in their 3D model so that they can use those, kind of non-destructively reference them, maybe modify them within the USD ecosystem, and then still be able to distill them and get them available on the web. So yeah, I think that's like our major interest is how do we make sure that the normal like native build of USD has native glTF support. And so utilizing some of the work you've done and things that are out there, ideally we'd like to roll this all back up into kind of the main USD branch.
I think a question in one of your slides, Pablo, I think you pointed to asset generator. Is that a sort of, are you automatically generating test assets or semi-automatically?
No, there's actually, I'm using 2 Chronos repositories for that. There's like the sample models repository, and there's another that is especially made for testing glTF importers. A lot of different.
You're not generating assets.
No, I'm using these assets.
So Sandy, related to that, I had a question on, do you feel, are there gaps for the test assets that you think would be, if the collective we were able to make new test assets, that would be helpful?
Yeah, everybody seems to be crying for test assets. Basically, it's the classic sort of miserable standards job. Like everybody wants it, nobody wants to do it. But so
maybe I can chime in there with my questions and some remarks as well. So like as some of you know, I think like we have also been working on glTF to USD, especially in the context of going through 3JS as converter, which is super valuable and brings a lot of like the features like Draco works, WebP works, all these kind of things, because they're already unpacked on like 3JS side. And I would love to align as well on test assets. Like we're also using the sample assets, but I also have like 150 or so of like what I call adversarial models that basically are designed to break all converters out there. And this is like to normal users, this is absolutely useless, but for implementers, it's very valuable to just have assets to try to break their converters. And this I would love to align around, like how can we make this more visible? How can we run these conversions? Like I'm not sure who of you knows the Asset Explorer stuff that we've been putting up with like a number of conversions. Like how does Blender convert glTF to USD? How does 3JS native do it? How does Needle do it? How does et cetera, et cetera? And I would love to amend that with like more of these conversions to hopefully like converge at some point on things that work correct and work right. So yeah, just putting that out there. I'm also super interested in aligning on like which assets do we all agree are useful to test, and where do we put them, and how do we make that public and visible?
Yeah, I just posted also a link to these other repository, the asset generator assets. These are small assets, kind of unit tests, you could say. I think the coverage is already pretty good. Of course, one way forward would be to identify some gaps, especially with the new functionalities.
Yeah, I mean, I know as the glTF folks are generating more extensions, I don't believe test assets exist, except for ones that are sort of carefully handcrafted.
Cool. Yeah, look, this is an area of high interest. And Felix, the adversarial models that you said, would you be willing to make those public and available to the community? Is that what you were?
Yeah, I'm working on that, basically using all the same formats as the sample assets repository, like so that you could just say, okay, pointing to that other JSON will give me just another list of like 100 or 200 models to test against. And then from there we could decide like which of these do make sense to be merged back up into the assets repository or something.
That would be huge. Cool. I see Thomas has a question.
Yeah, in this context, I remember that I had lots of trouble with the emission extension because the current checkers limit reasonably the RGB values of emission to 100%. But when the alpha channel comes in, you cannot achieve a transparent but glowing surface because it's all limited by the alpha channel. And when the transparency is, let's say, 10%, the opacity is 10%, then it's all dull and dim. So useless for specific cases. Did anybody else come in this trouble, and how can we?
So emission in
achieve
glTF
something?
has there's an emissive strength extension in glTF for going beyond 1.
Yeah, that's
This
something
this is the usual way.
we added that in the PBR TSG. The problem was that the core JSON schema of glTF limited that color to 100% and the color factor to 100%. So we introduced a separate extension called KHR Materials Emissive Strength, which is simply a multiplier. It just arbitrarily makes the color brighter by a number that's not bound at 1.0. So you can specify a color with the standard emission channel and then give it an emissive strength that's greater than 100% to get around this problem. That happened probably about 2 years ago, I think.
Thank you very much. And does it survive the round tripping with USD?
Depends on the exporter or the converter. Like with the needle one, it does. There it gets converted to like high emissive values. That being said, what you mentioned, like the interplay of emissive values and transparency is super undefined in like both glTF renderers and USD renderers.
Thank you for the input.
All right. Well, Pablo, once again, awesome presentation, awesome contributions to the community. Thank you for coming here.
Thanks again, and thanks for inviting me.
Of course, yeah, and please hang out for the rest of the presentations and any water cooler conversation if you're able to stay. So Keith, over to you if you want to do a screen share, and really looking forward to hearing more about the plugin you guys open source for USD.
Great, yeah. Hi everyone. So yeah, my name is Keith Blackstone. I'm an engineer over at Adobe. We recently, beginning of the year, open sourced a bunch of USD file format plugins. I'm just gonna kind of talk about that a little bit here. First off, USD file format plugin, we want to make sure that we take that foreign file format.
You're not sharing your presentation, Keith.
Oh, is it not sharing?
Yep.
Yeah,
looks good.
It's just not the full screen version. It's the slides.
Yeah, we'll just do the slides this way because I guess it's not picking up my extra monitor. That's fine. All right, we'll start with the first slide here. So file format plugin takes a native file format, makes it native to USD. The reason why we want a native file format plugin is allows for customization and optimization. And we also want to stress it's not just a converter, right? As kind of Pablo showed, we want this to work with USD cat, with USD view, and kind of make USD kind of own that file format as well. We've open sourced 6 file format plugins as of now: FBX, glTF, PLY, OBJ, SBS, AR, and STL. They're not finished yet, right? We're still in development, but they are pretty robust. We've been in development for over a year with these plugins, and they are shipping in multiple Adobe products today, which is great. And then the question, why open source these file format plugins? And we want this to standardize across the industry. It would make all of our lives easier if we're using the same import and export plugins everywhere. It would give the user a better experience as well. They could kind of understand what they'd have certain expectations met when they brought their files to different programs. And also the expansion of use cases, right? At Adobe, we probably aren't covering all the use cases for each of these file format plugins. And by open sourcing, we can get more coverage on that, more collaboration. I think it's a win for everyone. Diving into the USDGLTF plugin specifically, we're based on the Tiny GLTF version, which is GLTF version 2.0. We have supported a bunch of extensions. I encourage you to look at the README for a full list of the extensions we support and the extensions we don't support yet. The plugin also supports both importing to USD from GLTF and exporting back out to GLTF or GLP. And then we write the data via the lower level SDF API. Our first incarnation of these plugins actually used the USD stage API, which we found to be inefficient, especially when reloading a stage if some data has changed. So we've refactored them. They're much more performant, which is great. Plugin features, we spent some time extensively mapping, GLTF material models, USD preview surface. We do image compositing, which means we're able to create dynamic textures on the fly as we need to. We support embedded images in GLB, so those images are stored in memory. You don't need to write them to disk. You can export them to disk if you like, but it doesn't have to be. We have what we call experimental MaterialX support, which is the mapping to OpenPBR. You can enable that with a file format argument when you import. Everything is backed by the ASM, we call Adobe Standard Material Model. For all of our plugins, we use this as our transport layer because we don't want to lose different properties when going from one format to another. We want to preserve all that data when we import and export. So we use ASM to help achieve that. And then kind of as Pablo mentioned, we have some basic animation support, but animation in USD is challenging. And we'll kind of talk about that a little bit in an upcoming slide. Although we do have some work going into multiple animations and a skeletal animation support coming online soon. More features, the node hierarchy, I think, is what everyone expects, right? You have your full scene structure. We do geometry with instancing, so we're not blowing up the size of the format, the size of the file. We support cameras, round tripping, and then, like I said before, more details are at the README. That's really kind of our holy grail. For each one of our plugins, we have a README file that lists the features that it supports, it doesn't support, and kind of any extra information. With GLTF, it's mainly about the different extensions. If I do the USDV demo, so I have this mutant model, right? We load them in GLT viewer. Once the plugin is installed and configured properly, you bring them up in USD view and you see that as well, which is great. Similar with USD cat, works out of the box once it's installed properly. Plugin challenges. So as we talked about, animation clips versus the USD global timescale is a challenge that we're still kind of working through. There's a proposal to kind of help deal with this that we're investigating. Multiple animations is also troublesome as well. GLTF skeletons are flexible in their node hierarchy, which really complicates how you convert to USD with them. Blend shape support is a challenge. Normalization, interpolation, weight mapping. There's discrepancies between the different file formats to consider to make sure you get it right. And then dependency management. We use OpenImageIO for the ability to read images for our compositing step. But there's been some community reach saying, hey, can we get rid of the OpenImageIO dependency? And so maybe we'll go to STB going forward. It still needs to be evaluated. But overall, we need to take another dependency pass through. It's kind of been a while since we looked through that and kind of strip out anything we don't need. And then USD plugin build setup, it's just not trivial. Of the issues we've gotten on the plugin since we launched in January, probably about a third are just related to people's build and setup and not getting everything proper. It just takes time. I think one thing I want to do in the future is add, more like getting started pages, new to USD pages, just kind of really onboard people and hold their hands as they're getting used to these plugins. What's next for us? So we do monthly releases. So we started in January. Our third release was in March. The next one in April. We're hoping to resolve these GLTF skeleton issues we have, some with instancing and faceting issues. Lots of bug fixing. We have multiple teams inside of Adobe using these plugins, reporting issues. We're now getting issues on GitHub, which is great. And we're just prioritizing and trying to get those fixed ASAP. Longer term, we really need to improve our testing infrastructure. Very jealous of Pablo's CI GitHub Actions. We want to get that set up going for all of our plugins as well. Reduce dependencies, as I mentioned, and then also we want to develop a community-driven feature roadmap so people can kind of know what to expect. In at least each quarter, what we're trying to address. If people want to contribute to speed something up, then kind of know when it's going to fit our timeline. We just think that would be useful in general. And then in conclusion, Adobe is already shipping with these plugins. Modeler's shipping with 5 of them. After Effects is using OBJ import and GLB export. And we expect more products to be coming online this year and next year using these plugins as well. And we ask people to get involved, post issues, post PRs. There's a link to our repo. And as was mentioned in conversation before, we're fully on board with, transitioning this over to AOUSD or anyone who kind of wants to kind of get a more global force behind this and not just one company. We're totally on board. That's it. Thank you, guys.
Very nice. Thank you. Yeah, look, great job. I mean, great to see all the traction, both for the usage within Adobe and across the community. Let's open it up for questions. Who has the first question?
There are a few questions in chat.
Yeah, I can repeat them here. Like you mentioned, it's not a converter, but for me, it's always interesting. Like, can it be used as a converter to see like if something going wrong with the conversion or something going wrong with the respective USD runtime? Because otherwise, that is like hard to say. So can I just like in both directions say like give me the USD conversion for this glTF and give me the glTF conversion for this USD?
Yeah, so I mean, there's no command line to do that, but it would take a little simple.
But like in general, you can
do
USD cat with an output file, and that will give you the output that you want. There is a challenge with how we reference our textures. So we reference our textures relative as embedded files in the glTF file, which is needed for embedded files, but we also do it in order to be able to use image compositing to create on-the-fly images that are needed to do a more accurate conversion of the glTF material model to USD preview surface. So in order to do this properly, in addition to doing the USD cat, you also need to go through all the assets and extract the reference textures and extract them to images on disk. I guess maybe it works if you embed the images in the exported GLB file. I don't know anyone tried that, but USD cat can be used to do the conversion, but you can also do but you might have to do an extra pass for the images to get them out. We're hoping to add examples for this.
So USD cat with all the plugins correctly installed can also do the other way around, like it can give me a glTF pickout.
Yeah, it should work.
Okay.
I think so. Let me try that. Maybe not.
We will do a best effort to understand the shading that's contained in the USD file and try to map it to a glTF spec, to glTF2 spec plus extensions. So it will try its best, but USD could be an arbitrary shading graph based on a material model that we don't understand, and then we throw up our hands and just don't do anything. But if it's a USD preview service or the internal Adobe standard material, we will try our very best to get it out into a representative version of glTF's shading model.
Yeah, that would kind of be one of my next questions around like test files or round trips. Like I can assume you have some specific ones, so kind of similar to the earlier discussion. Like if you have specific test files, would be great if these are available somewhere. Like I mean, glTF to USD and back is like inherently lossy. So I'm always interested when someone says we do perfect round trips, what is actually going on?
We don't do perfect round trips.
Okay, so just round trips, not perfect round trips, sorry. Round trip still has kind of a notion of like bringing a lot of data with it. So it's always interesting to see like what does actually happen. Like
it's not you don't get a bit perfect version of your old file back. We can't
that
guarantee
for sure.
that.
Like
So
just mean
essentially,
like, for example, when going from a glTF that has like a skeletal hierarchy with stuff attached to it, like USD can't represent that. So when you convert that to USD and then go back, do you do an effort to restore like what glTF can handle better, or is it just like expanded then?
it's potentially expanded, particularly for this very difficult case with the skeleton animation. For shading things, we try to expand them and then remember, essentially, we leave some, in a few cases, we leave metadata around so we can compact it back because there's no native representation in USD. So yeah, the round tripping is trying to be, not to generate extra stuff that's not necessary, but yeah, it's nearly impossible to get it completely to be coming out the other side exactly right for all cases. I think for simple files without animation, without skeletal stuff, it's pretty good. Once you add skeletal animation, particularly the ones that are not well representable in USD, it goes a little bit off the rails because that's just a hairy case.
Yeah.
I've also confirmed that you can use USD cap to output glTF files and GLB files when the plugin is installed.
Given the complexity of the build tooling that you mentioned, will you be releasing binaries?
You're not the first person to ask for it. I don't know.
I just know that super helpful that NVIDIA is doing that with their like USD binaries, and that would be cool to just also have like a ground truth, download this and it will work, or at least on Adobe's machines, and then try if it also works on everyone else's. So that would be great.
Yeah, we've been hearing it from others. I think it makes sense to invest in providing those.
Other discussion?
Yeah, I'll just jump in. I had a few thoughts coming through, and again, really appreciate the effort. I think this is going to really help progress our kind of goals from like a 3D commerce perspective. I think like within the USD ecosystem, one of the things that's interesting to us as an authoring format is that you can basically have these non-destructive references, and you envision this plugin kind of being used for that. Like, so if a team is working in a, let's say they're doing like a layout or design, they're bringing in all these different models that might be in different formats. They could pull them into their scene, composite it, do whatever they want with it. But on disk, those glTF files don't actually need to be changed or altered or round tripped, right? They can just exist and show up in the scene.
That is absolutely supported, yeah. So if you want to keep your references glTF, that is supported.
Yeah, excellent. Yeah, because I see that as one of our use cases that we think would be helpful, especially in the ecosystem of commerce where people are building different tooling out for, layouts or design, planograms, etc. The glTF models that are maybe already out there, if they could just be brought in and then unaltered, or if the glTF gets updated independently, the reference can get updated. I think that's going to be a great use case. I was also curious on the texture conversion or baking that happens. What are some like examples or use cases where that would be in a glTF file that there might be? Is this like future node graph support, or like because there's only so many different things that you can do with a glTF PBR material. I was just curious if there were specific examples you can think of that a channel needed to be baked or converted.
It's things like what a glTF spec with performance orientation is very not flexible, which makes it very easy to read. It's very clear this is how it has to be. Like for instance, alpha is always the fourth channel in a texture, in the one that's also the base color. That is not a requirement on the USD side. So on export, we might have to take a separate, read the green channel on this texture, and this is the alpha. But on the glTF export, it needs to be the fourth channel on this base color text. So we essentially combine textures and remap them. There's also things where when we need to do some essentially analyze the textures, we need to look for them. For instance, transparency is very expensive if you turn transparency on, because there was an opacity texture, but it happens to be all white. It's actually an opaque object, but it was authored in a bad way. We go through the texture, detect, oh, it's an all white texture. It's a constant value, get rid of the texture. Oh, nice. Now opacity doesn't need to be on, turn that off, because it leads to all kinds of rendering artifacts and all kinds of rasterizers. So we do a couple of things where we combine textures to meet the spec requirements and also to get rid of expensive textures, particularly opacity being one of them.
Nice. Oh, thanks. That makes a lot of sense.
Are you handling cameras and lights with children on them and things like this?
do handle cameras. That's definitely supported. Lights, we have not heavily leaned onto them. They have been not in a, we don't support the point light extension yet. And also it has not been a heavy case. Like we're mostly focusing on glTFs that are individual assets and less scenes with lights in them. So we do not have support for them. I think we do something, but I'm not sure how far that is. And I would not expect advanced cases to be supported at this point.
Okay.
Great discussion. Other topics, questions? I mean, maybe a question from me for Keith and crew, just with respect to this working group, right? Trying to help, encourage and facilitate interoperability for USD and glTF. Are there things that you think, we should be doing, whether that's around trying to help sample assets, help any education, or?
Yeah, it's a good question. I mean, usage, things you've seen lacking that the community wants. You guys are kind of a little more closer to the community and kind of know what the needs are that you see lacking, things that we can help prioritize to get online quicker. That type of information is invaluable. That would be great.
Cool. Okay.
Yeah, any like sources of bad or good data is like appreciated, because at some point we really need to ramp up with the testing and validation side of things. But so I know there is like an official set of assets from in the glTF repo that we can use. But if there are other examples or places that are stressing more things, that is really valuable for us.
Felix, that's another +1 for your.
Also from my side, it's very important. Already a survey, for instance, who uses extensions would be very important for me.
Cool. All right, glad to see all the interest and alignment there.
So, but just to follow up on that question, I mean, the Adobe folks, are you planning to do test assets from your side, or I'm just asking because we're going to have this round tripping project, hopefully, as Guy was saying earlier, funded by AOUSD in Kronos. Just trying to figure out where the gaps are and where we can most usefully spend any funds and resources that we have. Thank you, Felix, for volunteering your adversarial assets. I love that term. But just to understand, is Adobe also generating test assets, or is that not on your roadmap?
I mean, right now we have a lot of internal test assets. We definitely want to get more that we can put up on the public repo and test against more regularly. Where that is in the priority of it all is, I think, yet to be determined.
Yeah. Okay. And maybe just to, from the discussions that have been here, maybe we can begin to kind of put some pegs in the ground as to how we can best cooperate going forward. I liked Guy's suggestion that if eventually the converters end up on AOUSD, because it's USD is kind of the hub that everything's going in and out of. That seems to make perfect sense. For the glTF test assets specifically, for testing that seems to make sense to just expand the existing glTF test repo. That seems to make sense as well. Would people agree?
Yeah, I think it's a great place to start. I know we've pulled some assets from there. I would assume others have as well.
Yeah. And we've put some effort into kind of rationalizing and tidying up that repo so we can continue to do that.
But aside from the repo, I think at some point it would make sense, I think, to start a project where you have software that will generate the test assets, because when you create extensions and with all the attributes and all the different types of inputs, it's like impossible to do by hand, all the variations. And I don't know if that should be within Kronos or within the MSF, or it's where whoever has the bucks who wants to pay for a project also.
Yeah. Yeah.
Yeah, at least from my perspective, like automatically generating test assets kind of works for like fuzzing and kind of making sure that various like random combinations work. But At least for the work we're doing, where like people use almost all of the Kronos extensions without even knowing, and both on exporting and runtime side, that just results in real world issues with extensions. And then usually I try to craft this case that may be like a 500 megabyte file, but as like a test asset that just has the same breakage. So far that has been far more effective than any random or any auto-generated stuff that I was able to come up with. Like, just because the real world cases are typically what you can't imagine in your auto-generated assets.
Has anyone tried AI yet? Ask GPT to design adversarial assets, see what it comes out with.
It's generated 100,000 test cases.
Other questions? Sorry, again.
Again, just kind of poking the edges of what we might put in scope of a funded project. I think it was Guido on a previous call here at the forum mentioned that another gap that the project might usefully fill is kind of tabulating results from running tests, because again, Adobe might not be doing that part of kind of the whole loop. Is that still the case? Is that something we should think about as we're scoping the funded project?
Yeah, that's definitely still a gap we have here for sure.
Okay.
And Mike, I know we talked about this in our conversation too. I think it's partly the tabulating all that. It's partly the engineering work, and in the conversations we've had, we believe, to be determined, but we believe that the engineering work being funded kind of by the Adobe side, the NVIDIA side, and Pablo, whatever you want to contribute, is mostly taken care of. It's test asset generation and sort of tabulation of the results and testing the edge cases.
Mm-hmm. Yeah, another question I'd kind of bring to the group around how we want to validate a round trip, right? Like, so you can't just necessarily look at the bytes at the end of the in and out, right? And the visual tool that I think Pablo has is pretty interesting too. But I'm just curious, like, what do we want to consider to be acceptable criteria for everything? Like, what makes a round trip successful, right? Like, at the end of the day, you're going to get an asset out that's maybe a little different than what you put in, but identically visually or functionally the same. So how do we like measure that? Should we use a tool like the Asset Auditor, for example, which was something that it's kind of like a deep packet inspection tool that I built for Kronos as part of a project that we did about a year ago. And so something like that to me comes to mind as potentially a way to analyze the final model. But I'm curious if others had thoughts on what would make a good test.
I think it also like defining what it actually is, like one, because if you want perfect round tripping, you would probably have to like embed all the data that's lost in some kind of hidden data or metadata wherever the appropriate place to put it, and what are the expectations and what a round trip actually is.
Mm-hmm. Yeah, so for example, if you had individual texture channels and then in the end you've got a combined like map, maybe it's a better glTF file in the end anyway, and so that's the desired outcome. So you're actually maybe getting something better out of the pipeline than what you put into it, but it is going to make sure potentially be a little bit different.
Yeah, the way I've been phrasing it to people was you can either have a structurally correct conversion or a visually correct conversion. You usually can't have both.
Mm-hmm.
And I guess the right answer will be, what are people doing in the real world most? I mean, is visual fidelity the key?
At least in our use cases, that's 100% the visual correct representation. Like, people are producing glTFs in like a million variants and cases, and then they expect them to work on iOS and visionOS. So in our case, it's 100% like visual conversion needs to work. So structural conversion doesn't matter in that case.
I would agree with that. And I would also add that on the Blender side, we often see people want to make a change. And in particular, if they're bringing it into USD, you can almost be certain they're bringing it into an authoring format for the sake of making some intentional change to the asset, right? So it's not going to do you any good to preserve secret data from the original if the user's intent is to make a surgical change to the asset in the USD environment. And then they expect that when they export it back to glTF, anything that they didn't change needs to round trip cleanly. Plus, it needs to include whatever intentional change they made in the USD environment. I think that's the main use case for round tripping.
That's actually, if I may, I would like to add one more question for Keith here on the conversion side. Like, does the round tripping only work because of extra metadata in the files, or does it also work without that metadata?
We definitely use the extra metadata. I'll default to Florian if he's still here, if you know it's required for it. Yeah.
It's very few cases where we do this. I think it's like a the USD preview service, for instance, does not only differentiates between, I think, it has an opacity threshold. It doesn't do the 3 cases of opacity for that glTF has, like between opaque and I forgot the different version. So that's I think the only
there's
case
a cutout version and a blend version.
I think that's the only case where we had to do something extra. Everything else we currently try to map to USD, even if the USD shading model wouldn't use it. Like certain primvars, we would export them, but for instance, wiring up like the material, Pablo described this. The material model for glTF clearly says take the vertex color, multiply it by a base color, multiply it by what the texture is. The USD preview surface is too simple. It cannot represent that. There's no multiply node, no anything. So essentially, we carry things forward like the vertex color and write it out to the other side, even though the shading model doesn't look at it, because we know it has to flow through to be correctly on the other side. So there's versions where the USD preview surface, because of its limited shading model, would not correctly represent the shading in the glTF side. But on the export side, we would export all the data again, and in the proper glTF viewer, all the pieces would come together again. It would be looking correct again, even though the intermediate, because its limitations of a current USD shading model, would not hold. The MaterialX case is exactly what this would solve, because that shading model is more flexible. It can handle the glTF spec properly, which the USD preview service currently does not. So we're not relying heavily on it. It's really a few cases where we encountered ourselves that we needed this round tripping to work. People complained about it. And so we did surgical fixes for this. And it's in the code clearly documented where we're doing this and kind of what's essentially special metadata tags to do something.
It would be great if there's a way to exclude that metadata. Like, at least that's like when Unity made their USD import export plugin for Unity, it was kind of the same problem. It all just worked because of extra metadata. Like, the materials were all broken. They only worked for round tripping into the same application, basically. So like this makes it really hard to test and to verify if things actually work.
What is actually worked in this context? I think that's the maybe part of the question is,
well,
is the round tripping the test case, or the to USD and USD back out? And then we need to define what's the correct translation, right? And what's the
round tripping,
or structural,
like, if a tool states it does round tripping, but then the format it has in the middle basically only works because of a ton of metadata and a custom runtime, then I would not consider this a round trip through that format. Like, basically in Unity's case, they were exporting from Unity to USD. The USD files that came out were entirely broken, but they worked when you put them back into Unity, so they claimed round tripping. So because of all the metadata, like, it worked when you moved that USD file through whatever processing and then back into Unity, but it didn't actually work in other tools that expect well-formed USD. So I would just like to avoid that pitfall, basically, like not saying that it is like this. That's why I was asking how heavily is relied on metadata, and if there's a way to tell it to please not do this because tools may strip it away anyways, and so on.
But, you know, with the round tripping, one exception to the visual fidelity is if my data is, you know, scientific visualization, and if I care very much that it's accurately, I need to do like measurements on it. I don't necessarily care that it looks the same from the round trip. And actually, the metadata may be like one of the most important parts to keep for that stuff.
But that entirely depends on the workflow. Like I'm just wary of like saying, like we have really great material round tripping if actually it relies on like 90% metadata, for example.
The glTF does have a metadata node that can have quite a bit of information, not necessarily directly related to rendering or how the geometry is set up. And with some of the work that we're beginning to look at now, it's really important to keep that metadata when moving through the whole process. So if you're working on importers, exporters, converters, whatever the particular term is appropriate for you, make sure you carry that. It's the KHR JSON LD, let's see, XMP JSON LD extension. So stuff represented there becomes really important.
It's like everything else in the world. It depends on your application.
Well, if it's in the glTF to begin with, it should be back there when done, unless the user intentionally removes it along the way.
So folks, just looking at the time, and I see some folks have been dropping off at the top of the hour here. I thought that we could maybe enter the water cooler for folks who can still hang out and chat, but we'll just thank Keith and end the official meeting. So Keith, awesome presentation. Great to see all the productive Q&A here.
Thank you all so much, and thanks for letting me present. It was great.